So let's take up some common problems related to Coulomb's law in this lecture. For example, very basic problem is that, let's say if I have 6 charges on the vertices of this regular hexagon, then what is the net force on +1 Coulomb charge kept at center O? So in this case we are seeing that Q is repelling this +1, so it will force +1 to move in that direction. This Q will force +1 to move in this direction. These two forces will get cancelled. It will try to move it this way, and the bottom charge will try to move this +1 upward. So these two forces will get cancelled. This will push it here, this will push it upward. These two gets cancelled. So net force on +1 Coulomb charge, net force on +1 Coulomb charge will be 0. One more example, if I take the same hexagon, Q, 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 Q and Q charges are kept on 5 vertices, but this vertex is kept free, then what is the force acting on this +1 charge which is kept at center O? In this case I can easily see that this will be getting cancelled by this force will get cancelled by this upward force. Only the force due to this Q is not going to get cancelled because there is no charge at this point. So the force due to this charge Q will be the remaining force. So this way I can say that the force acting on this +1 is K Q1 Q2 upon distance square, which is A square. So this will be the force acting on the charge +1 kept at the center. Now let's take if I have let's say if I have a clock, it's 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. -12 Coulomb, -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -11 and -12. So these are the 12 charges kept on the digits of the wall clock, and if I keep a +1 Coulomb charge at center, and now if I say that the R needle of clock is in direction of motion of +1 Coulomb charge, then find time in clock. So the question says that if this +1 Coulomb is moving, let's say in this direction, I don't know in which direction it's going to move, but if it moves in this direction between, let's say towards 6, if it moves in this direction, then the R needle is pointing towards this 6, then what will be the time in the clock? Obviously the time in the clock will be 6 o'clock if the R needle is exactly at 6. If the R needle is exactly at 7, then the time in the clock will be 7. If the R needle is between 6 to 7, then the time will be 6:30. So that way we have to tell the time when R needle of clock is in the direction of motion of this +1 Coulomb charge. So this question is quite simple. You can easily see that -12 is attracting this +1 and -6 is also attracting this +1. So obviously this -12 will attract this +1 more severely as compared to this attraction of -6. The dominance of this attraction force of -12 is exceeding the bottom force by 6, by a factor of 6. Same way, here I can see that minus 11 charges are attracting this plus 1, and in this direction only minus 5 is attracting this plus 1. So this force dominates the force of minus 5 by another factor 6. Same way, the force due to minus 10 will dominate by 6, force due to 9 will dominate by 6, force due to 8 will dominate the force due to minus 2 by 6, force due to minus 1 will be dominated by the force due to minus 7 in this direction. So I can see that the force towards this digit 12 exceeds the other force, the bottom force, by 6. The force towards 11 exceeds the other force that was along plus 1 and minus 5 coulomb. So this minus 11 force is exceeding by 6, this 10 is exceeding by 6, this 9 is exceeding by 6 as compared to this 3, 8 is exceeding by 6 as compared to this minus 2. So this way I can see that these are 1, 2, 3, 4, 5, 6 forces starting from 7, minus 7 up to minus 12. So I can easily say that if a vector is in this direction, it has a magnitude of, let's say, 6 Newton forces there, and one more 6 Newton forces there in this direction, then the resultant will be exactly in between these two forces. Same way here I can see that the angle 30, 30, 30, 30 and 30, the total angle is 150. 1 time, 2 time, 3 time, 4 time, 5 time. The total angle is 150, and the resultant, as I said here, the resultant is exactly in between these two forces. So same way here in this case also, the resultant of all these 5 forces will be exactly along the bisector of all these forces. So I measured this total angle to be 150 degree. So the resultant force will be along at an angle of 75 degree from this 7 or maybe from this 12. So if I measure 75 degree from this 12, then how will I move? 30, 30 and just 15. So the force, the resultant force will be exactly in between 9 to 10. When the R needle is between 9 to 10, then the time in the clock will be simply 9:30. So that's the answer of our problem. I didn't solve anything, I just got the answer just by observations, right? One more example you can take. Let's say if I have 3 charges Q, Q and Q. This is an equilateral triangle of side length A. Obviously the angles will be 60. If somebody asked me to calculate the force, acting at charge kept at vertex A due to other two charges. So I have to calculate the force acting on this Q charge due to the other two charges. I can easily see that this Q will be repelled by this in this direction. Let's say this force is F, and once more this Q will be repelled by this Q along this direction. This angle will be 60 degree because this is 60 degree, so this is a vertically opposite angle. So the resultant of these two forces will be F square plus 2F into cos 60 degree. So this will give me F net, which is simply root 3F, that is root 3 KQ square by distance, which is A square. So this way we can easily calculate the force acting on this charge due to the other two charges.